The electric vehicle revolution is fueled by a single crucial component, lithium ion batteries. As Tesla's EVs continue to soar in popularity and other automakers look to ramp up their own production, the demand for lithium has skyrocketed, causing its price to absolutely explode higher. In just 2 short years, the price of lithium compounds have surged from a modest 7,000 US dollars per metric ton up more than tenfold to a staggering $88,000 per ton, with Elon Musk himself stating that lithium prices have gone to insane levels, dubbing it the new oil. Now, while the price of lithium has pulled back slightly with rising interest rates and a slowing economy, it's one of the few commodities that's still up massively, keeping costs high for companies such as Tesla and eating into their profits and gross margins. However, Elon Musk isn't sitting still. He's vowed to get Tesla into the lithium business if prices remain high, and so it's no surprise that Tesla is now moving full force to try and rein in the costs from this valuable commodity, as Elon Musk has plans to destroy the price of lithium. And before we continue, stop using Yahoo Finance, stop using Google Finance, and have a look at our website, themarketisopen.com, where we have instant stock quotes and a brand new set of financial data going back 15 years, and it's all freely available. Lithium is currently mined and produced by a variety of countries around the world, with the largest players in 2022 being Australia, followed by Chile, China, and Argentina. While demand for the metal is expected to outpace supply, lithium production has actually quadrupled between 2010 and 2021 and continues to grow year after year. But mined lithium is different than the lithium that goes into battery packs for electric vehicles. It must be processed and refined into battery-grade material compounds. While China is third on the list in terms of lithium mining capacity, the country actually produces more than 3/4 of the world's lithium-ion batteries. China gets most of its lithium from Australia, and they also control the majority of the world's refining and processing capabilities. On the other hand, the United States accounts for just a small percent of the world's lithium production, attributed to a single lithium brine operation in Nevada that belongs to Albemarle's Silver Peak site. That said, there are a number of major projects underway in the United States, including Piedmont's Lithium Hard Rock Project, Lithium America's Thacker Pass Claystone Project, and Standard Lithium's Lithium Brine Project. The United States is rich in lithium reserves, capable of meeting the demands of the electric vehicle industry. However, extracting this precious metal is not without its challenges. Environmental concerns have cast a shadow over some mining projects, causing delays and hindering progress in tapping into the nation's lithium reserves. These ecological considerations are proving to be a significant obstacle in unlocking the full potential of the country's lithium resources. However, despite the abundance of lithium ore on the planet, Tesla has recognized that the true bottleneck to meeting the world's and its own lithium needs lies in the refining process. Elon Musk has emphasized the need for a dramatic increase in lithium refining, as the current capacity is simply not enough to keep up with the rapidly growing demand for batteries. In a recent Tesla conference call, he urged entrepreneurs to enter the lithium refining industry, highlighting the software-like margins and potentially astronomical profits to be made. Elon Musk stated that while the mining of lithium ore is relatively straightforward, refining it is much more challenging and presents a lucrative opportunity for those willing to invest. He likened the margins in the lithium processing industry to basically printing money. Up until now, Tesla has received lithium from a variety of suppliers. For instance, they have a deal that was signed in 2021 with Ganfeng Lithium, a top Chinese producer, that will supply lithium products to Tesla between the years of 2022 and 2025. Companies like Livent and Albemarle have supply contracts with Tesla, and China's Sichuan Industrial Group has been providing battery-grade lithium hydroxide since 2020. Tesla also has a deal with junior mining companies such as Liontown Resources in Australia to provide spodumene concentrate to Tesla starting in 2024. And just recently, on January 3, 2023, Tesla amended its agreement with Piedmont Lithium to deliver 125,000 metric tons of lithium between the second half of this year to the end of 2025. Now, not all lithium is created equal. There are different types of lithium products and various stages of refinement needed in order to produce battery-grade materials for electric vehicle battery makers such as Tesla to make use of. Lithium deposits must first be extracted from the ground through mining operations, most commonly in the form of spodumene, lithium brine, or clay. Lithium spodumene is a mineral composed of lithium aluminum silicate that's commonly found in lithium-rich rock deposits called pegmatite. The process of extracting lithium from spodumene involves crushing the mineral and then processing it to remove impurities. Another popular source, lithium brine, is a liquid solution of lithium salts that is found in subterranean salt lakes, which are dry lakes that are seasonally flooded, also called sailors. These brine deposits are typically found in arid regions such as the Atacama Desert in Chile and the salt flats of Bolivia. Lithium is extracted from the brine by pumping it to the surface, where the water is then evaporated to concentrate the lithium salts. A third source is lithium clay, which is a type of lithium-rich sedimentary deposit that's formed from the weathering of lithium-rich rocks. Lithium clay deposits are typically found in dry desert regions and are often located near lithium brine deposits. Lithium is extracted from the clay by a process that involves leaching the lithium from the clay with a solution consisting typically of sulfuric acid. Now, of these three main sources of lithium, spodumene rocks, brines, and clays, around 49% of global production currently comes from spodumene, with the remaining 51% coming from brines. While there is a potential for using certain clays as a source of lithium, there hasn't been any commercial production from this source as of yet. However, at Tesla's 2020 Battery Day event, the company outlined its plans to enter the lithium mining industry by exploring this novel approach, extracting lithium from clay. But unlike traditional methods, Tesla intends to utilize table salt in this process, a departure from conventional practices that use acids. According to Tesla's Senior Vice President Drew Baglino, this innovative extraction method has the potential to reduce lithium costs by 33%. While this is an untested method at scale, Tesla's forward-thinking approach holds promise for the future of lithium mining and the electric vehicle industry as a whole. According to a patent filed by Tesla that was revealed in mid-2021, entitled Selective Extraction of Lithium from Clay Minerals, Tesla illustrated that current methods of leaching clay with sulfuric acid and hydrochloric acid not only leach out the lithium, but also high concentrations of various other impurity metals. When removing these impurities, more lithium is lost, which reduces extraction efficiency. And furthermore, they say that high acid consumption and complicated leach solution purification methods also make the overall process less cost-effective and not environmentally friendly. Tesla proposes a new method, which at a high level involves mixing sodium chloride, which is table salt, with clay material and performing a high-energy mill, then doing a liquid leach which results in a lithium-rich solution. This innovative approach aligns perfectly with Tesla's highly vertically integrated business model, where the company has control over every aspect of the supply chain, from mining to the final customer experience. As a result, Tesla is well positioned to fully leverage the benefits of this new lithium extraction method. In addition, back in 2020, Tesla secured access to 10,000 acres of lithium-rich clay land in Nevada, where it has proposed to use its new method of extracting lithium from the ground. This is a step in Tesla's plan for crushing the sky-high prices of lithium. If its new method is successful at scaling, not only will Tesla be adding its own lithium into the mix, but with a 33% reduction in extraction cost, it will improve yields. Also, because Tesla released this patent years ago, other miners may take note and copy Tesla's process, which could bolster the global supply of lithium, thus affecting worldwide prices. The amount of lithium inside an electric vehicle is actually quite low. According to Drew Baglino, Senior Vice President at Tesla, he states that there are just 5 kilograms of lithium content in one of Tesla's vehicles. If Tesla plans to produce on the order of 2 million vehicles this year, that equates to a reasonable 10,000 metric tons of lithium. But at $80,000 per ton, that's $800 million of cost for such a small portion of the overall vehicle. That's equivalent to a meaningful 6% of Tesla's total profits for 2022. And as Tesla plans to achieve an ambitious vehicle production rate of 20 million cars per year by 2030, this could multiply these numbers by a factor of 10 times. It's unlikely that Tesla wants to be spending $8 billion on just lithium in 2030, even if prices remain flat. However, the true source of high costs in lithium production can be found further downstream in the production of battery-grade raw material compounds, such as lithium carbonate and lithium hydroxide, which are essential for Tesla's lithium-ion battery manufacturing. Both compounds can be extracted from spodumene at a fairly comparable cost, but converting from one compound to the other through chemical processes requires additional equipment and therefore expenses. Lithium carbonate is a white powder produced mainly through reacting sulfuric acid with spodumene to produce lithium sulfate. It's followed by the addition of sodium carbonate, which is then precipitated and dried to result in lithium carbonate. On the other hand, lithium hydroxide is made through the roasting of spodumene and calcium hydroxide. But this process becomes even more expensive if salt lake brine is used as the source material. Now, lithium carbonate is used as a precursor for making the cathodes of lithium-ion batteries. It's normally preferred because it's more easily processed and has lower production cost compared to lithium hydroxide, whereas lithium hydroxide is used as a raw material for the production of lithium salts, which are used in the electrolytes of lithium-ion batteries. It offers thermal stability and reduces the risk of battery degradation. However, when used in high nickel battery cells, lithium hydroxide is the preferred compound for creating the cathode materials as well. So NCM 622 and NCM 523 batteries can either use lithium hydroxide or lithium carbonate. But NCA or NCM 811 batteries must use battery-grade lithium hydroxide, and these are the main types of battery chemistries that Tesla uses. Generally speaking, products made from lithium hydroxide usually have better performance and boast longer-lasting batteries. Lithium carbonate can also be converted into lithium hydroxide, but it takes an additional chemical process and therefore added cost. But this explains why Tesla has started construction of its own lithium hydroxide refinery in Texas. This is a $375 million facility that's said to employ 165 people plus another 250 construction workers over the next 2 years, according to Electric, and it's set to begin operations by the end of 2024. Tesla's proposal for the refinery stated that its purpose was for developing a battery-grade lithium hydroxide refining facility, the first of its kind in North America, as well as facilities to support other types of battery material processing, refining, manufacturing, and ancillary manufacturing operations in support of Tesla's sustainable product line. And so while this could still take a few years to be completed and get ramped up in terms of production, it will help solidify Tesla's own supply chain for lithium raw materials. The prices today are elevated because of low supply and high demand, which is expected to get even worse over the next few years as the electric vehicle market grows rapidly. But lithium isn't a scarce material. It just hasn't been processed in the ultra-high volume needed to support so many EVs, and that's what's causing the spike in price. It's all profit margin for producers, like Elon Musk has said, since the actual cost of extracting and processing the lithium is relatively low. And so Elon Musk is taking advantage of these high margins by cutting out the middlemen who are collecting on the order of 90% of the profits and having Tesla produce these minerals for themselves at cost. If Tesla can bring their new lithium mining project online and refine the material on their own, especially in the United States, which completely lacks refinement capabilities, then they may be able to offload a huge amount of their lithium demand from traditional markets, thus increasing the supply. This could also reduce the need to import lithium. Now, just as when commodities see high demand and prices skyrocket, the opposite occurs when commodities see an excess of supply, and the prices tend to crash even more rapidly. And that's part of Tesla's plan. It doesn't take much to cause volatility in a commodity since they're highly sensitive to supply and demand fluctuations. Not only will Tesla's own refinery and potentially clay mining operations allow for supply chain stability, but because they're such a big player in the market, especially in the United States with currently a 75% market share in EVs, they're partially responsible for contributing to the increased demand and therefore price spikes in lithium. By removing themselves, at least in part, from the equation, global prices may tank, allowing Tesla to further save hundreds of millions and later billions of dollars in battery costs, whether it produces its own lithium or buys it from suppliers. Ultimately, Tesla will pass on these savings to benefit consumers with lower-priced electric vehicles. So do you think Tesla will be successful with its new methods of mining lithium from clay, which has never been commercially accomplished before? And do you think in 2025, when Tesla's lithium refinery is up and running, the first of its kind in the United States, if it will indeed help to free up supply and drastically reduce the exorbitant price of lithium? Don't forget to watch my video on BYD's Atto 3 and ATT electric semi-truck. Please hit the like button and subscribe, we would really appreciate that. And a huge shout out to all of our patrons that help to support our channel. Your support helps us to continue to make great content. Thank you guys so much for watching.